Hi, my name is Paul Roberts and I'm a chemistry teacher here at Andover College. I've been teaching chemistry for 8 years and today I'm going to talk you through how to do the core practical of distillation. So there are some important safety considerations in this practical. First of all, we're using a Bunsen burner, so it's very important that students know how to safely light a Bunsen burner and how to control it. Also, we're going to be heating the water in an elevated position, so it's important to clamp the conical flask. First part of the practical setup, you're going to need to prepare the bung thermometer delivery tube apparatus. An important safety consideration in this delivery tube setup is that there are no blockages in the delivery tube. Any blockages could result in the overpressure of the heating system and could result in injury. So first of all, just check that there are no blockages. This can be done by carefully blowing through, and you can feel air coming through out of the other end. So now we have our delivery tube apparatus set up. Now I'm going to add some ink to the conical flask here, and I've got some black ink. I've prepared this by putting a few drops of just fountain pen ink in 200 mils of water. Need to add approximately 50 centimetres cubed. The volume isn't critical, we're going to have some left over at the end anyway. Now, to ensure a nice smooth boil, we need to add some anti-bumping granules. The amount of these anti-bumping granules isn't critical, just a spatula full in the flask is fine. So now we have our ink and anti-bumping granules in our conical flask. We can now put in the thermometer, bung delivery tube apparatus and push it in nice and snugly. Notice at the other end here we have the delivery tube going into a test tube, and the test tube is in an ice bath. That way when the water boils it will condense in the tube and will continue to be condensed in the test tube. Okay, so I'm going to light the Bunsen now. Always light a Bunsen with the hole either closed or partially closed. And I'm going to slowly increase the temperature of the Bunsen now. Now the Bunsen is going to be heating fairly vigorously, and I'm wanting to bring the water, or the ink, which is mostly water, up to a boil. Now I can keep an eye on the thermometer there, but the thermometer should start rising as I heat it up, and it's going to take a couple of minutes for the ink to come to a boil. So whilst you're heating the ink, it's very important to keep one hand on the Bunsen burner. That way if the ink starts to boil quite violently, you can quickly move the Bunsen out of position. I can just see the ink just starting to boil now, bringing it to boil, and I'm being mindful not to leave the Bunsen there. The temperature is still rising, and at this point I can just start to see condensation appearing in the delivery tube. So now this is a kind of boil we're looking for, a nice steady rolling boil. I don't want to heat it too violently. If I heat it too much, then the ink will actually boil all the way to the top of the bung and will get carryover into our receiver flask. I can now see liquid slowly coming down the tube. It's condensing here in this tube. Now bear in mind, this tube is going to be very hot. This tube is going to be at 100 degrees, so don't touch it. And I'm continuing this in and out type process where I'm heating the ink, keeping it on a nice rolling boil. Now after a couple of minutes of doing this, you should be able to see through the receiver, through the ice bath in the receiver, that we have collected some water. And at this point, I can turn the Bunsen burner off. Now I'm not going to do anything to the apparatus until the boiling has stopped and until there's no more steam coming out of the delivery tube. Bear in mind, you can see the thermometer now. The thermometer is at 100 degrees, and so is the whole of this apparatus. However, my ice bath and my receiver is actually quite cool now. This is actually cool to touch. Now I can carefully remove the ice bath. Doesn't matter about any water dripping here. And I can see now when I take out my test tube, my receiver test tube, that I've got pure water remaining. And there's no ink in the original sample. So it's very important now to keep an eye on the temperature and not to start disassembling the apparatus until the temperature drops to 50 degrees. Everything here will still be very hot. The rest of this can go down the sink as there's no hazards in pure water. So there are a few common problems that can occur in this practical. First of all, you get black ink in your test tube, in your collection vessel. This can be caused essentially by the ink boiling too vigorously and the ink carrying over into the tube. A simple remedy to this is not to heat the conical flask as strongly and constantly be moving the Bunsen burner in and out. Another problem can be if you're using a small conical flask, then it boils too quickly and there isn't the volume for the boiling to calm down. Again, I suggest using a 250 ml conical flask. Now the other problem might be you get no water at all in your receiver. Now this can be due to there being a hole or not a snug fit in the thermometer and delivery tube, or there not being a snug fit in the bung into the conical flask. So in summary for the distillation practical, first of all, you prepared the delivery tube apparatus and made sure there are no blockages. We've also looked at how to safely heat the apparatus and make sure there's no carryover. And last of all, we've looked into some troubleshooting of how to get over some problems that might occur. Now the practical I'm going to talk you through today is the core practical of chromatography in ink. This is a very straightforward practical. It's something the students might have come across before, even at primary school, but I'm going to give you some guidelines today of how we can get some very clean and accurate results. As with all chemistry practicals, we have to consider safety. The solvent we're going to use in this chromatography is water, so there's no hazards there. But as ever, if you're working in a laboratory, it's standard precautions to wear a lab coat and safety glasses. So we're going to start the practical now. The first thing we need to look at is the beaker. Now the beaker is going to dictate the dimensions of the chromatography paper. It's very important that the chromatography paper goes into the beaker and it doesn't touch the sides. So what I've used here is a piece of filter paper, and I've drawn my chromatography paper outline on there and cut it out. Now once we've got the chromatography paper in the beaker, checking the height so it's just at the top of the beaker there. What I'm going to do on the chromatography paper is mark a line about 2 centimeters up from the bottom. Now it's very important that I mark this line in pencil. As with all lines here drawn on my template, everything needs to be marked in pencil, otherwise it will run and interfere with the results. I've marked my line now in pencil, and this is what is known as the baseline. Now the next part is to dot the inks on the chromatography paper. Now I've got 4 marker pens here. 2 are marker pens and another 2 are felt tip pens. It's very important that they are non-permanent markers. Permanent markers won't run in the water solvent. So, as with chromatography, all chromatography, less is more. It's very important to put a small amount of residue on the chromatography paper. And so, what I can do first is practice on another piece of paper and just practice a small dot there. You can see the size of the dot there. It's really quite small. Students will be tempted to put a big dot like that. Unfortunately, if they do that, they're not going to get good results. The residues will run into each other. So I want a very small dot, and I'm going to put them equal spaced on the chromatography paper. 1, 2, 3, 4. So you can see they're very, very small dots in chromatography. Now we're going to suspend this in the over the beaker, And so I'm just going to attach the chromatography paper to a pencil. Now this can actually be done beforehand for the students. You can always give them the paper already with the pencil attached. So what I'm going to do now is check the height of the paper in the beaker. And you can see there now the paper isn't touching either the bottom or the side, and this will give good results in the chromatogram. Now take the paper out. The temptation is to add the water with the paper in the beaker. Unfortunately, if you do that and you accidentally get water on the face of the paper, you'll have to start the chromatogram again. So take it out, and you're only going to need to put in around about 2 centimeters depth. Just checking that the height looks good. Yeah, that's nice. And popping the chromatogram in the beaker. Now the temptation is to move the beaker now. It's very important that we leave the beaker nice and still. If you move it and the paper touches the side or the water washes over the baseline, you're going to get really quite bad results. So just leave the paper nice and still for 20 minutes. So it's been 20 minutes now, and you can see now on the chromatogram that there's been quite good separation. You can see on this paper here how we've had no separation of the dots either side, but the 2 dots have completely separated. And you can actually see on the chromatogram that these 2 black inks are made from 2 different mixtures, both though containing a blue and a pink. Now, at this point, it's important to leave the chromatogram to dry. And I'm going to leave the chromatogram to dry. You can pop it in an oven or on a windowsill, but don't lay it flat. If you lay it flat, then the inks will start to smudge. You'll also notice that I've removed the chromatogram with about 1 centimetre from the top of the ink to the paper. And that's because the residual moisture in the paper will still continue to rise up the chromatogram. And it's very important that you don't let it go right to the top, otherwise the chromatogram will continue to rise until it's left, the dyes have left the paper. So here's another chromatogram I prepared earlier, and this is dried out completely. I'm going to remove the chromatogram from the pencil. Now on the chromatogram, we're going to mark some key areas. First of all, is the solvent front, and you can see the solvent front is the furthest point at which the water has risen up the chromatogram, and I'm going to mark that across the top. So I've now drawn my solvent front, and I can measure this solvent front. Now the distance of the solvent front from the baseline doesn't really matter what units you measure it in, but this is a millimetres ruler, and so this is 64 millimetres. Okay, so we call this the solvent front, distance of 64 millimetres. Now, I'm going to mark the key dyes points of each residues in the chromatography. You can see there's a blue residue there, and then I've got below it a kind of a pinky residue. And on the other one here, I have a blue residue there, and again a slight pink residue, and you might be able to make out a very faint, another kind of pink residue there. And I put my cross at the darkest points of the residues. I've not just drawn a circle around them. What we do now is measure the distance of the residues in millimetres. And this distance here is 42. The distance of this residue is 59. The distance of the blue residue is 62. And then for the other residues of the other ink, this residue distance is 59, And the blue residue is, again, 62. The blue dye has travelled an identical distance on both samples, suggests that it is an identical chemical, and the same for the pink one. Notice I haven't measured the residue distance of the first and the fourth sample I put down. That's because they haven't left the baseline. I mean, I can put a 0 there and a 0 there. That means essentially these two dyes are insoluble in water. So now I've marked up my chromatography paper, I can calculate the RF values. Now to calculate an RF value, the easy equation, RF is equal to the residue distance divided by solvent front. So if I'm going to calculate the RF value for the residue at 59 millimeters, that will equal 59 divided by my solvent front, which is 64 millimeters, and that gives me a value here, 59 divided by 64 of 0.92. Now there are no units on an RF value. That's because you're dividing millimeters by millimeters. And if you're looking at your significant figures, it's important that the same significant figures are used as are in the measurement. So I've given my answer to 2 significant figures. So what we've done today in this core practical is to prepare the chromatography paper, to run the chromatogram accurately and precisely, and then to calculate RF values.